When we describe rope, we have to be specific. The wheel gets a lot of credit for our progress, but humans have been using rope for a very, very long time, and we should be good at it. First, there are the various materials ropes can be made from. They can be made from natural fibers, synthetic fibers, or steel wires. Sometimes these materials are used in combination. The term rope is used for both fiber and wire ropes. The term cordage is used to denote fiber ropes only. Natural fiber ropes are made from materials like hemp, sisal, manila, coir, and cotton. Synthetic or man-made fiber ropes are made from materials like nylon, polypropylene, polythene, and Kevlar. Here are some ropes made of the natural fiber, cotton. Rope users appreciated cotton ropes on small boats and yachts because it is soft, however it is expensive and has been superseded by the great range of special-purpose synthetic ropes. Here are some ropes made of the natural fiber, manila. Manila remains pliable when wet, and is usually employed where a rope with elasticity is required. Manila is not good for lifting, as it can stretch 40 to 50%. Manila is also buoyant. Here are some ropes made of the synthetic fiber, nylon. Nylon is the strongest of all ropes in common use. It is used for absorbing shock loads, such as when anchoring, mooring or towing, because it has the ability to return to its original length after being stretched. It also has good abrasion resistance and can last several times longer than natural fibers. Here are some ropes made of the synthetic fiber, polypropylene. Polypropylene floats, that makes it a rope of choice on the water. It is used extensively in the fishing industry. Here are some ropes made of steel wire. Ropes made of steel wire are more likely to be part of your boat's rigging. Over the years, humans have devised numerous ways to put ropes together. In this module, we are going to look at twisted, 3-strand rope and braided rope. Here are some twisted 3-strand ropes. One of them has the 3 strands unraveled. Here is some braid line rope unraveled to show its construction. When we are describing a rope, we refer to its diameter. For example, we want to attach 90 feet of 3/8-inch polypropylene rope to a lifebuoy, means the diameter of the rope should be 3/8 of an inch. We should be interested in the breaking strain of a rope to ensure that the rope does not fail and injure us, or others or damage property. For ropes made of the same material, ropes with wider diameters can withstand greater loads or strain before breaking. When we look at the strength of the different materials we have looked at so far, we see their relative order of strength from weak to strong is, manila, polypropylene, nylon. Let's put some numbers to this. A particular size manila rope is tested and breaks when subjected to a load of 4 tons. The same size rope made of polypropylene is tested, and breaks when subjected to a load of 7 tons. The same size rope, made of nylon is tested, and breaks when subjected to a load of 9 tons. Elasticity is the rope's ability to stretch temporarily and return to its original length. Elasticity in a rope is not helpful for lifting but is helpful when mooring or anchoring. A property like buoyancy is useful during mooring, because if the rope falls into the water, it would be less likely to foul the boat's propeller. Buoyancy is not desirable for anchoring where we want the rope to lie on the seabed. The process of rope making consists of taking fibers, which are short lengths, and spinning them into nettles. The nettles are then twisted into long lengths to form a yarn. The yarns are twisted to form a strand and then laid up to form cordage. In the composition of synthetic cordage, the nettles are formed from long continuous filaments. To prevent the rope unlaying, the strands are laid up in the opposite direction to the yarns. If the strands are laid up right-handed during manufacture, then the yarns in the strands will be laid left-handed, the nettles would be right-handed. This is the most common type, 3 strands laid up right-handed, available in sizes 3 mm diameter upwards. Solid braided ropes are constructed from either 12 or 18 strands, braided together, normally over a central core. Available in sizes 3 to 12 mm diameter. The safe working load, or working load limit is the maximum safe force that a piece of rigging, towing or lifting equipment or accessory can exert to lift, suspend, or tow a given mass without fear of it breaking. The safe working load is usually marked on the equipment by the manufacturer. Where the SWL cannot be marked, and in all cases, all rigging components should have test certificates. Professional seafarers have to ensure those certificates are kept on board. The safety factor is taken as 1/6. That means the safe working load is taken to be 1/6 of the breaking strain in tons. The diameter of fiber and steel wire rope is given in millimeters. The safety factor of fiber and steel wire rope is 1/6. Thus safe working load can be taken to be 1/6 of the breaking strength for fiber and wire rope. So safe working load of a rope is approximately the diameter of the rope squared, times the factor of safety. For example, a 30 mm nylon rope will have safe working load of 3 times 30 squared. That is 2,700 kilograms. While a 15 mm wire will have safe working load of 8 times 15 squared. That is 1,800 kgs. It is common practice to allow a factor of safety of 6 in general marine work for both fiber and wire rope.